Welcome to section 5.1. Chapter 5, we are focusing on applications of derivatives. So we're going to be starting to talk about how these all get used. And sections 1, 2, and 3 are all tied together. They're under a broad concept known as curve sketching, in which we're going to be talking about why graphs look the way they do, where they're increasing, where they're decreasing, when they're curving, how the functions curve between maxima and minima. So the way generally it's going to be broken down is in section 1 we look at finding maxima and minima. Section 2 we start talking about where do we know where it's increasing and decreasing. And section 3 we start talking about what's called concavity, which is how it curves as it increases and how it curves as it decreases. So there's going to be a series of videos that we go through here for section 1. I'm trying to make them shorter, even though it may be more videos. So this first video is talking about what are known as absolute extreme values, or absolute extrema, also called global extrema. So I can also call these global. And what it says is that we have to know our domain, and that is very key to this, is everything we're doing with this in these sections, we need to know what our domain is. But within that domain, a y value is an absolute max if and only if that y value is greater than or equal to all the other y values for the x's in that domain. And then it's an absolute min if and only if that y value is less than or equal to all the other y values for the x's in that domain. And this is pretty much what we think of when we think of minima and maxima, or the absolute highest and the absolute lowest. What we have to pay attention to is that we stay within the domain. So some examples of this. I'm going to look at cosine of x and sine of x. So looking at a domain from negative pi over 2 to pi over 2, including the endpoints. Cosine of x is the blue here. I have an absolute maximum of 1 at x equals 0. And when we say what is an absolute max, that's the y value. Where it is the x value. So the absolute max is 1. It's at x equals 0. I have an absolute minimum, and actually I have it in two different places. Over here, I have an absolute min of 0 at x equals pi over 2. But I also have that absolute min of 0 at x equals negative pi over 2. So I can have an absolute minimum occur at more than one place. They just have to be equal to each other. If I look at the sine of x, again from negative pi over 2 to pi over 2, including those endpoints, I have an absolute minimum of negative 1 at x equals negative pi over 2. And I have an absolute maximum of positive 1 at x equals positive pi over 2. So again, absolute max or min, the what it is the y, the where it is the x. To have a look at how absolute max and min are affected by our domain, let's look at x squared. So if I look at the graph of x squared here, if I look at just the domain of our function, the usual being negative infinity to infinity, so all real numbers, my absolute minimum is down here at the vertex, and since I'm asking what it is, I'm looking for the y value, which would be 0. And then there is no absolute maximum because there's always a y value that's higher than another one. If I now restrict my domain and say it's just from 0 to an x value of 2, including the endpoints, Well, now I still have an absolute minimum of 0 at 0, but now I do have an absolute maximum at 2, which would make the y value 4. But now let's say that instead of having that, whoops, I'm sorry about that. Instead of having that opened or closed at the endpoints here, let's say I open an endpoint, so not including 0, but including 2. Well, I still have an absolute maximum of 4 when x is 2. But now at 0, I never actually reach that vertex down there where x is 0. And I can always get closer to it. And each time I get closer to it, my y value goes lower, but I never reach it. So there really is no absolute minimum because even though I'm approaching the 0 for an absolute minimum, I never reach it. And then if I look at it I don't include either endpoint here. Well, now, just like before with part C here, there is no absolute minimum. But now, because my absolute maximum would occur at 2, but I never reach it now, I just get closer and closer. So there's now always a y value that's closer to it. There's no absolute maximum now either.